before technology was readily available, standard deviations, for example, were often calculated manually. And so here's where that would come up. So if you look at the formula for standard deviation, it involves this little guy right here. Now, we did this once, and then we never did it again with technology. But if you doing this manually, this is a pretty inconvenient way of doing it. So what was often done instead was, we would, using algebra, you'd expand this out to x squared minus 2x x bar plus x bar squared. And then you'd have each of these pieces added up, which ends up being the sum of x squared minus 2x bar, the sum of x, plus the sum of x bar squared. Now, without making you all vomit, there's your sum of x squared that you would need. The sum of x is also there. So that number can be plugged right there, this number plugged right here, and then x bar can just be plugged in here.
Got it.
So, I mean, it was just, I think it's just a holdover from those days.
Okay.
Ignore them. Not important at all. Great question, great question. Linda, go ahead.
So,
I'm sorry if this upset you, buddy.
So that would only be done in L1, not L, or would you do?
I ran them through L1.
Okay.
Yeah. You could also, I mean, you could also, if you wanted to.
Do 1 through 29 and then.
You could go 1 through 50 in L1 and then put how many of each in L2, but I think that's a little bit overblown.
Okay.
Because the problem with that is, I mean, you end up with more work than it's worth. I think you have so many zeros.
So just follow the instructions that you gave us.
Well, I mean, well, the thing is that sometimes you do want to use distributions, and sometimes you just want to use raw data. I think this is where raw data makes the most sense because you just got a string of numbers, and I was trying to go over there. I got a little Excel spreadsheet together with a map of Alaska, the correct size, and I was going to collate and give you a dot plot, which we'll come back to. We'll come back to it momentarily.
Okay, let's see if your clock's right.
Cool. All right, let's take a look. Let's take a look at our data thus far. Oh, you can't see any of that. Sorry.
Okay, now you should be able to tell.
I'm going to put this here temporarily.
So what would we use for the frequency to make a...
If you were doing it that way, you'd have to put... So 16 occurred, 22 occurred, 5 occurred. You'd have to put those in as your data. Your frequency would be how many people went to that many states. So for example, I noticed that there are a couple 22s. So you'd put 22 in L1, and then in L2 next to 22, how many people had been to 22. That's why I think it's more trouble than it's worth, because you're typing way more than just the raw data at that point. Does that make sense? And Linda's question and Carly's next question are wonderful in that there's no easy answer for that. There's no easy answer as to when to take raw data and make it a distribution. This is a pretty obvious case of when you shouldn't, because you end up typing a lot more than you have to type otherwise. Yeah, please,
Are you
Kelsey.
using like totally different data?
I think that's left over. I think.
Yeah.
Yeah.
You're freaking people out.
It's part of my problem for jumping on questions as soon as they're asked rather than trying to finish what I was doing.
I thought, what did I do wrong?
Nothing! Nothing at all! Let's do it! I'm sorry, everybody off. Stat, count, one of our stats, boom. You guys get this?
Yeah.
Okay, thank God. So, we have an average of 17 states-ish. 17 states, yes? What else we got? We got a plus or minus 10 states, holy plus or minus. So what does that mean? Roughly 2/3 of the data are between
7 and 27.
7 and 27? Mathematically, yes. What's the assumption there? I just asked a question and you guys gave me a wonderful mathematical answer. If the data is bell-shaped. We haven't looked at that yet, have we? And we'll get to that, I promise. Do we have a median? Do we have a median?
14.
14!
Where do you find that at?
Scroll down. Good question. Good. Scroll down. If you scroll down, you get some really, really neat numbers, all of which I want to explore today with you guys. Pat, I see you up there. There's your 43, max X. I see the median of 14. The min, smallest data point was 4.
Cool.
Yeah? There you go. Is that you? Excellent. And then you get this Q1 and Q3. I want to come back to those guys because right now they don't mean a whole lot, but they mean a lot in general, but right now not so much. So median's 14 states. So the question is, am I allowed to use the 2/3 rule for one standard deviation? I don't know. Let's take a look at the data to see if it even looks remotely bell-shaped. It's hard to see in raw form like this if it's bell-shaped or not. It just looks like a bunch of scattered data, depending on how you guys sat in class. So ready? Check your stat plotter. Second y equals. Mine's turned on.
Do we want it on or off?
On, for sure. Make sure it's looking at your data. Mine's in L1, there we go. Once it's in L1, what's the best way to, what's the easiest window to get?
The third one. Oh.
Well, this is already set up, ready to go. It's on, it's set to histogram, it's set to L1, frequency of 1, all's good. Zoom 9 is your favorite to get right to the data. Zoom 9, ba-boom! There's our data. Gorgeous. I recommend some finagling, just my opinion. I'd like to finagle a little bit, because the TI will always give you 6 or 7 or 8 bars. We can break it up a little bit more if you want. My recommendation, I think. I'm going to press the window button. It's set in the mix, it's the min at 4. I got no problem with this. Although I'm going to mess with it a little bit if it's okay with you guys. I'm going to change the min to 0 and the max to 50. And the reason I'm going to do that, as you might, maybe you know.
There are 50 states?
50 states, and nobody went to all 50. 43 was the highest. What do you think we should set as a scale? Your call. How about 5? Jolene says 5. So 0 through 5, 5 through 10, 10 through 15. I love that idea. So much my voice is cracking. So I'm not going to touch the Y's yet. I'm not going to touch those Y mins and Y maxes yet. We may have to adjust them, but I don't think we're going to have to. We may want to make them smaller to get the bars higher. Let's just press graph now. What do you think? Bell curve.
Yeah.
Bell curve, yeah? Not so much a bell curve? Votes. Folks, Veronica's like, I'm not totally convinced it's a bell curve. It is definitely a little bit skewed, for sure. As a matter of fact, there's a calculation you can do for skew that has you find the difference of X bar and the median, 17 and 14, and then divide by 10, the standard deviation. And if that number gets too big or too small, that's negative, it implies great skewness or acceptable skewness. If you look at your variation homework, it's buried in there. Let's not get in a fist fight about it. Let's not get in a fist fight about it. I mean, it's up to you, really, if you decide it's bell-shaped or not bell-shaped. I think it looks relatively bell-shaped. The thing that upsets me about it not being bell-shaped is it doesn't have this run-out tail over here like it does here. And you can see that behaving in the statistics. The median is less than the average. That's because who's the average heading towards? Not to blame Pat, but Pat. And not to blame 39. Who was 39? Yes. Claire. Not to blame Claire, but Claire. The average is heading towards Pat and Claire and the other 30s. Whereas the median's like, poo-poo. I really don't care that Pat's at 43. I just know he's above me. He could be 15, 43. It's irrelevant. Doesn't matter where he is. So the median is giving us a less detailed look at above and below, whereas the average is actually calculating the distances as well. So the reason I bring up this data, and the reason I love, and you can keep messing with this if you want to, you can knock down the scale even more, make the scale 2. There's our data. Now the problem with making it too small, if you make it too small, it ends up, all the shape disappears essentially. You get so micro-analytical that you lose any kind of underlying detail where the bell shape would be. So if you say it's bell-shaped, that's fine. If you say it's not bell-shaped, that's fine. But if it's not bell-shaped, you've got 2 choices now. The problem with not having bell-shaped data is you can't use these. You can't use the average and the standard deviation together. They should only be used when you don't have skewed data, right? That's the whole point. The whole point of X bar and paired up with S is that they should really only be used when you have roughly bell-shaped data, or at least when you don't have highly skewed data. In other words, the center is basically at the center. And we're talking about center in 2 different ways there. The center in Patty's terms of where the majority of the data is roughly equal to where the arithmetic mean is, which you brought up about an hour ago. Thank you for that, by the way. Fantastic. So, what do we deal with if we can't use this? Well, if you're calling that bell-shaped, bless you, that's fine. But what if you're like, you know what, I'm not sold on it being bell-shaped. I did the skew calculation, it's 0.3. I don't like that. It's not close enough to 0. Excellent. What do? You need some other measures. We've already established one. One was the percentile rank, yes? Another one, believe it or not, is actually tied back to measures of center. The median was one of those, wasn't it?
Right.
The median was actually in there. What's the fundamental difference between these measures, how they're calculated, and how these guys up here are calculated? Give me a verbal kind of explanation of the differences in how the percentile ranks and the medians are calculated, and say an average. I'm going to pull this back so we can see that better. In your opinion,
The percentile rank and the median don't accommodate for what the actual data points are.
boom! What do they care about, friend?
How many there are.
Above and below, yes? Nice. That's why I like to call this topic something different to keep it different from this. They're all doing the same thing. They're all talking about a data set. But these guys here are actually talking about not only is 43 bigger than 39, it's 4 bigger than 39. Not only is 43 bigger than 14, it's that many bigger than 14. This doesn't care about how many. It doesn't care about the absolute distances. It just cares about the relative distances. Is it above or below? So I like to call this measures of relative position. Measures of relative position. Relative position. This is what I like. Now, why do we give it another topic? Why wasn't center and variation enough?
Shows that it doesn't care about how many, it cares about.
It cares about how many above and below, but it doesn't care how far above or below. Like, it cares, for example, Pat, you're at 43. We know where you are within the data set, but we don't care that all we care is that you're above everybody. Not how much you're above everybody. How much you're above everybody is actually accounted for over here. But just the fact that you are. Think of the Facebook quiz. As soon as that data looked too skewed to us, we backed away from the average and the standard deviation, and we said, okay, how many of my friends have more friends than me? Not how many more, just more. So you'll lose a little bit of detail with this, but it allows you to deal with any shape distribution that you want. That's the upside. It's a trade-off. You do lose a little detail, yes? But you can actually do mathematics on this if you have any shape distribution that you want. Yay, we kind of like that. That's kind of nice. That's kind of nice. Please, Jolene.
Could you use relative position on a bell curve?
Of course you can. But the thing is, the median and the average are going to be the same thing. Yes, great question. Can you use relative position on a bell curve? Hell yeah. You can use Chebyshev on a bell curve if you want to. The thing is, the more restrictive you get with the if statements. If data is bell-shaped, then 2/3 are within one standard deviation. If data is bell-shaped, blah, blah, blah. That's great. But you can use all this stuff on less specific data sets too. That's why it's nice. You can use it anywhere you want. And that's, I think, why it's used so ubiquitously in healthcare. You don't have to know the underlying distribution, although heights of, as you saw, heights of 2-year-old white American males appear to be roughly bell-shaped with a slight skew in the left tail. Cool? Everybody right now, practice your percentile rank. Figure yours out. Figure your percentile rank out. Now I'm going to show you a TI trick that might help you do this. You got your data in your TIs, yes? It would be very helpful if that data was... Say that again? It's all in pounds. In order.
Oh, yeah.
Because that way you can find your weight and count those below you, yes? So, if you want to order your data, there's a real quick way you can do it. Just go to your home screen. You know where you do all the commandy stuff from? Like second mode, probably. Yeah, second mode or clear or something along those lines, yeah. Not second mode. Second mode, then press the clear button. It'll be clear for you. There we go. Press the stat button. Either sort A or sort D. It doesn't matter, but if you're going, I think sort A probably makes the most sense, depending on where you are in the list. If you go to sort A, and then tell it which list to sort, in this case L1, and then press enter, it says done. Now when you go back and look at your list, they're all in order. And now it's easier to find your particular points.
How do you do the L in there again?
The second one. Cool. Take a few moments right now. While you do that, I'm gonna go ahead and oh, it's different on yours, isn't it?
Yeah.
We can find this. We can find this. We can find this. Hang on. We can no. Hang on. Sit on it. Your L1 is list one, probably not L1. So I can show you where those are. They're in a bar link. Second that, and you have to go find it. You only have to find it once. Once you found it once, it'll always be there. So list one is somewhere down here. There it is. Boom. So when you run one bar stack,
Yeah.
editor, here we go. There you are, right? So when you go to calculate or list or tools, I'm not sure where you're sorting.
This one is
Calculate.
so you're
There's one bar stats.
59.
So you got one bar stats.
Yeah.
Just put the list one.
Yeah.
And then you have to change it. I'm gonna do it for you. Now it's done.
yeah, 59%.
Nope, it'll always be there. They keep blah, 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 blah,
Does
blah.
that make sense?
Done. Now the sort thing we have to find. I'm not exactly sure what that is.
Basically. So what was it about?
So that's also
Oh, ops. There it is. Sort list. List one ascending.
oh, that's how you write it.
There at the bottom, up to the top. That is going to take more than 2 minutes to explain. Yeah, it's in there. It's just a matter of, I can send you a PDF or I can explain to you after class.
Okay.
Cool? Please. Yes, I'm going to cut the camera off so we're not getting my discussions.
So you just have to
Exciting though they might be.